Hello students, welcome to Vyas Certification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 12th. The chapter that we're dealing with currently is integrals, and from this chapter 7 of class 12th, now is the turn of exercise 7.6. This is a relatively big chapter. In integrals, this particular chapter, we cover indefinite integration as well definite integration. So first 6-7 exercises are based on indefinite. After that, the exercises are based on definite integration and its properties, right? So we'll be dealing with all of those exercises. This exercise 7.6 is based on indefinite integration and one particular method of integration. That is integration by parts will be discussed here with you. So along with the questions, we'll see the method and what all the other important things related to that. So method, integration by parts is not a difficult thing. Integral of fx into gx dx. So integral of product of two functions is equal to first function times integral of second function minus Maha integral of derivative of first function into integral of second function, right? So that's what you have, right? So first function keeping constant, integral of second function is involved, then you differentiate the first function, integrate the second function, and you multiply them, take the Maha integral of all of those things, right? And those two terms will give you the final integral, right? That's what you see. Along with a few more important things, that which function can be taken as a first function, which function can be taken as a second function, is what we'll see over here, along with the questions, right? So beginning with the first one, what does the question say over here? The first question says integrate x times sin x, right? How do we do that? X times sin x. So integrate x sin x dx. This is the integral that we're looking forward to. Yes, and the rule says, by part says, okay, when we have product of two functions dx, or you can write it as integral of u v dx, where u is fx, g is dx, right? So in other words, this is also called, sometimes also known as UV rule, right? Product of integrals, product of functions and then the integral. This is equal to u times integral v dx minus integral of du by dx times integral v dx and whole integral. This is the result. This result can be derived easily with the help of ideas of product rule of differentiation. The integral can be derived using that. And the important thing over here, two important things. What is that? That in integral v dx, there is no need to use constant of integration. No need to use constant of integration. That's what you can say. If I use constant of integration, that is actually redundant. So it is better that you don't use that integral, a coefficient of integration, constant of integration. The second thing is the choice of u and v. And how do we decide that? There's a rule for that. Okay, this particular rule has been missed in the NCERT, but I'll have to explain that. So inverse, I stands for inverse, L stands for logarithmic, logarithm, A stands for arithmetic, algebraic basically, not arithmetic, algebraic. T stands for trigonometric, and E stands for exponential. This is how you choose functions u and v. So inverse functions would imply that you have sine inverse x, cosine inverse x. Those are very complicated, right? Logarithm in itself is also complicated, log x, something related to that. Algebraic will be something related to this. This is x, x power 1, x power 2. There's some x plus 1, x plus 2, something of that sort. Trigonometric functions will be sine x, cosine x and all. Exponential function will be e power x type of things, right? And you see, we are supposed to integrate v, so v has to be integrable first of all, right? And do you know the integral of logarithm up till now? Frankly speaking, no. Do you know the integral of inverse functions up till now? No. So v cannot be chosen from here. V has to be chosen from here. Okay, and u, the other function, will have to be chosen from here. For example, you have an algebraic function and a trigonometric function. So trigonometric function will be v and algebraic function will have to be taken as u. That's the key behind it. If you have, let's say, logarithmic and trigonometric function, so logarithmic function will have to be taken as u and this function will have to be taken as v. Although logarithmic into trigonometric, you will rarely encounter that, but this is the order that you have to follow, the rule of I late, right? And you can clearly observe, since you are integrating v, these functions are easy to integrate, right? These are difficult to integrate. So v has to be chosen from here, this side. If you have both trigonometric and exponential, still both are easy to integrate, but you'll take v as the exponential function, as v and trigonometric function as u. That's what you'll use. That's a rule. So these are some extra things which you needed, and once you're aware of this formula, this particular integral will not be difficult. What we'll do is, we'll first use u and v, right? So algebraic and trigonometric, this will be v and this here will be u. And integral will be, integral of u v dx will be u integral v dx minus derivative of u into integral v dx, right? This is what you'll have. So u remains constant, integral of sin x dx is what I get, minus integral of derivative d by dx of this algebraic function x times integral of v dx, which is sin x dx, and maha integral of this whole expression, right? The big integral of this whole expression. What is integral of sin x? This is minus cos x, right? So this becomes minus cos x minus derivative of x is simply 1, integral, this is 1, integral of sin x. Okay, once again, we are not supposed to use, no need of c, right? No need of constant of integration and integral of v dx. This is minus of cos x dx. This is what you have, right? And after this, this is minus x cos x, which is okay. This becomes plus integral of cos x, which is sin x plus constant, and yes, constant of integration will occur now. After this final integral, you'll write that constant of integration, and this is my final answer for this question over here, as you can clearly see. Is that okay? Yes. If you want, you can verify using differentiation. What is that? Differentiate this. So differentiating this will, differentiation of minus x cos x will be minus of cos x, keeping cos x constant, derivative 1, minus x, derivative of cos x will be sin x with a minus, and derivative of sin x will be cos x. Constant term, derivative will be 0, this term goes with this, and this is what remains. That is the integrand, right? That is the integrand, and yes, that the integral of this will be this function that has been verified. This is a complete solution, and these are some points, important points related to integration by parts. That's the solution and answer of this question.